And this graph is just showing the comparison data of the 3/4 sprint times. So we can see our chosen performer, it took them around 4 seconds, about 4.2 seconds to complete the sprint. The group average was in fact around 3.6. The NBA athlete was just under 3 seconds, and the better performer actually performed better than the NBA elite, and they actually completed it in 2 seconds 50. So we can see the differences that obviously the differences in between our performer and an NBA athlete. We would expect to see the difference because of obviously the vigorous training that NBA athletes have, and as our performers are only amateurs for our college, there's a clear difference in their speed and velocity and their ability to generate the force needed quickly to meet their peak velocity they can run at and sustain it. So from this we can determine then that our performer would need to work on their acceleration at the start of their sprint to make sure they can produce the force needed to reach their maximum velocity faster, and to perhaps try and combat the issue of deceleration to try and sustain their performance rather than decelerating and accelerating again. So if we look at the sort of shapes of the bar chart, we can see that we're not massively different to the better performers and the NBA athletes. We still manage to sort of keep within a good time to complete the sprint test, but in order to reach that level we would need to implement measures into place and strategies which will be explained in 6.4 as to how to improve. So now we're going to look at the results of the vertical jump test, and as we know in basketball, being able to jump is very vital because basketball is such an explosive sport and it has elements that require, especially jumping for shots and rebounds, would require a lot of explosive power to be generated really quickly. So we can see from the first graph the comparison of the vertical jump heights. Our performer managed to jump around 30 centimetres in total. Compared to the group average, that was around 45 centimetres. The NBA athlete, which was a massively high jump, around 118 centimetres, and the better player, which managed to jump 60 centimetres. So we can see that in terms of our jump height, from the height shows us that we didn't manage to generate enough power in order to increase our height to necessarily a much better performer like the NBA or the elite performer. So we didn't reach our peak jump force. So this is perhaps a strategy that could be a weakness of the performance, and therefore we would implement strategies in order to try and increase the height of the jump, to increase power, as it's so vital in basketball, and this is the sort of level we would need to achieve as an elite stand. This sort of value is showing us how much power you actually need in a vertical jump in order to be able to be successful in performing rebounds and shots. So it's vitally important. In terms of the two performers, we can see that the better performer jumped twice as much as this performer. So we can see then the differences in that. Maybe this performer is less experienced in basketball, a beginner perhaps, and is quite new to the techniques and hasn't really experienced this sort of having to jump quite high in that before compared to the better player. So perhaps they are more experienced and therefore which is reflected in their score. In terms of the comparison of peak power in the vertical jump, we are using the chosen player's mass and jump height in order to determine their peak jump force, which we have calculated and represented in a graph. And we can see that the chosen performer generated 3,000 watts in the vertical jump in terms of their power, compared to the better performer, which actually managed to produce 6,000 watts, so double what the chosen performer managed to achieve, compared to the NBA athletes, who were able to generate powers of around 8,500. So you can really see the comparison in these three performers and how. So the NBA athletes produced 8,500, we only produced 3,000. So it's about 5,000 difference in watts. So it shows you how vital that peak power is in vertical jump and how these athletes are able to achieve their peak jump force much more quickly than, say, the better performer and the chosen performer. It further demonstrates how important power is in basketball and such a key component. So in order for our performer to improve, we would at least need them to be reaching around 6,000 watts in order to be considered to be producing enough power in order to rebound and shoot successfully. So it really highlights the differences between our chosen performer and NBA athletes and perhaps their weaknesses, so we can put these strategies in place in order to help them improve. So in terms of evaluating the numerical model as a whole, we can look at some advantages and disadvantages of the overall model. So firstly, we have that it is most effective for elite performers. This is because the qualitative data can be quite hard to interpret, and therefore trying to give feedback to lower level or beginner level performers can be quite difficult to give them feedback. They may find that quite difficult to interpret and to explain, so in order to improve their performance, whereas it's most effective for elite performers because it allows you to provide them with the knowledge in the advanced details in order to refine their performance and therefore make tiny adjustments to make their performance that much better. And they would be able to interpret that and understand it because they're experienced in that sport and they understand what they need to do. It's just putting those strategies in place to make it easier for them and more specific. The next point to make is that technology and equipment is very effective in analysis. The technology is very advanced, as we've seen with software like Dartfish, Coach Pro's software allows you to slow down the video, replay the video, overlap images, compare to elite performers, looking at angles, and so on, biomechanical components. It can be very effective and makes analysis a lot easier. So you can gain that quantitative data that can be interpreted in graphs, charts, ways that can be used then to be delivered in sessions by coaches. Another advantage is that data can still be gained using simpler methods. So like we didn't have access to the advanced biomechanical lab equipment, so we adjusted our data collection to use, say, our phones and 2D cameras, which obviously is less effective, but it still allowed us to gain data with some degree of accuracy. So it's good in that case, so it can be used perhaps in more maybe elite basketball players, but not like a elite standard, maybe like amateurs, but not beginners. So it can still be useful, you can still gain data. Another advantage is that quantitative data can be useful in goal setting. By producing a perfect deemed numerical model, and this quantitative data can give players something to work towards. Like we use the NBA draft data, we can then use our performers and then show them that, right, this is what the amount of power you should be generating. For example, 8,000 watts, you're only generating 3,000 watts. Therefore, then they can put goals in place and strategies in place in order to help them increase their peak power, so they can at least try and aim to be like that elite standard. So the data can really help in goal setting and giving those performers something that they want to achieve, and in turn a goal. However, on the other hand, we have some disadvantages of the numerical model, and this is that advanced equipment can be difficult to use. can be expensive and hard to gain access to. I'll just say gain. The equipment can be very difficult to use. This is why specialised analysis is required by analysts who are specialised in that sport to do, because coaches can find it quite difficult to interpret and use. So therefore, this can be quite expensive and takes some time to do as well. As we said, very expensive, and it's hard to gain access to as well. It's very hard to gain access to biomechanics labs unless you are an elite standard athlete. If you're a low-level beginner, you're probably not going to be able to go into a biomechanics lab and actually use the equipment. Which is the same as us, we didn't have access to it. It's quite expensive, so we had to sort of use what we had, and that can be disadvantage of this model. Some people won't have access to it, so you'll have to use much simpler methods, which may not give you as much accuracy. Another disadvantage is academic understanding required. So this is linked to the first point. It requires sports specialists to review it, peer review it as such, to make sure that the analysis is accurate. So for coaches, it would be quite difficult for them to actually provide an academic understanding of the data collected. So as we said, analysts would have to be used, and therefore this can be quite time consuming to find analysts and can be quite expensive as well for them to interpret the data. Another point is that it's not as effective for beginners or lower level performers, as we've said, because it's quite difficult for them to interpret the quantitative data, what it actually means. So they would benefit more from qualitative data, perhaps verbal feedback from their coach saying, instead of doing this, you should do this instead, blah, blah, blah. It's hard for them to look at a numerical value and think, well, what should I be doing? So it's hard for them to interpret. And the last point is it just considers some components, not the technique. So in sports like basketball, it considers factors that we need to produce force, and we need to have power, and we need in order to produce the skill, but it doesn't actually take into consideration the technique, and therefore where the players may be on the court. That may affect how they actually execute sort of the skill and generate the power. Whereas, for example, if they're sprinting for a shot on goal and then there's a turnover, it might be quite difficult for them to generate the power in order to reverse their direction, then accelerate. So it doesn't really take into consideration the technique of the skill and sort of the components that are needed in order to generate that. But overall, this model has some very useful applications that can be used, but as everything, has its disadvantages as well. And lastly, this is my reference list from where I got my information from. Slide 2, slide 3, and slide 4.